Hello, class. I'm here to talk about problem 74. I thought it was important to cover problem 74 as you will see something very similar on your midterm. So I'm going to be covering here. 74 really just asks for two questions, but I have add some other questions that you will see again. So that's why I put it here as well. If you just answer me this two, that's fine, but I would strongly advise you to keep going on the video and watch how to calculate this. So um, the probability that you're gonna get a better grade in your midterm, it will increase, I guarantee you. Okay, so starting with the data student grades on a chemistry exam, and then it gives you the grades, ask you to construct a stem and leaf plot and ask if there are any potential outliers and why. So we're going to cover that. Well, the first important thing to do is to go ahead and put the data in order, which I put it over here. It makes it easier, especially when we calculate this as well. Okay. So now what are we going to do? We're going to look at how many stems we have. So we have, they call stem and leaf because there is, the stem, and then from there the leaves come out of the stem. So right here we actually have four, but the reason is because the six, if you notice, there is no 60s. So 50, 90, and then 80s and 70s. Okay. So if I would ask you how many stems are in my plot, you can say there are four. In this case, there are four. Truly four. If you would say five, I would have to consider as well because one, two, three, four, five. There's no 60s, but it's if you would, you have to include it. You cannot make a graph where you're gonna skip from five to seven. So, okay, now let's start uh, plotting the information. So on five, we have on the five digits we have one. Six, we have nothing. Seven, we have six. We have seven, we have eight, and we have nine. And in eight, we have one, two, four, six, and nine, we have nine. Okay, so the A, we're done. It's right here. So why, if you look at the numbers like this, it really makes no sense. So let's say that you turn this 90 degrees. You can potentially now see the two peaks of the graph over here. Just imagine some bar graphs right here. These are the two peaks. And this is the left tip of my bar graph. This is the right tip of my bar graph. So which would go like from this point up, up, and then down. Okay. So now the question is asking you, are there any potential outliers? Outliers are the ones that don't fit the data. I don't know if I mentioned that before, so I'm mentioning it right now. If you're talking about simple linear programming, you will learn that anything above two standard deviations, it's considered an outlier. And that's why I'm going to cover it here. So, but just by looking at it, you could potentially say that 51 and 99, they are outliers. Why? Well, 51 is about 25 points, is 25 points below the next exam value, right? Equals 75 minus, okay? And 99, and then also there's another one here on the high side. 99 is 13 points above the nearest exam value. So you can see they're clearly separated from the data. These are my two peaks over here. That so without even if you haven't had any of this information, and I'll just give you, if you haven't had any of this, okay, and I'll just tell you this, I'll say where are the peaks. You can say the peaks are on 70s, and on 80s, correct? Right there, without even telling you anything else. That's why it's important. Stem and leaf are pretty simple when you're trying to do a quick visualization of the data. It's right here. Okay, so you could answer right away, and then they ask you, are there any potential outliers? Yes, 51, 99. And let's see if we can confirm the potential outliers. Just keep in mind what I just told you, that about two standard deviations above, or should I say below or above the mean, are considered potential outliers, or that don't fit with the data. Okay, so right now these are the additional questions that you will see again. So how do I calculate the mean? um, Excel gives you all these formulas, so you really don't have to calculate them. So let me show you with the formulas how to do them. So when it comes to the exam time, you can just go ahead and refer to this video. My mean, all I can go is go equals, and instead of typing mean, I'm gonna say the average. The average of these numbers right here, close my parentheses, there are 10. Okay, I just select and enter. So my average of this data is 79.3. Okay, let's just say that I would go even further, which I'm not going to, and say I just wanted the mean without outliers. Okay, so what would you do? You can go equals to the average, and I'm not putting 51.99. I just want to know the peaks. What was my average of the peak? Was an 80.37, 38. And if you would round totally up, is an 80. So you say the average really of all these eight values is an 80. Okay. My median, all you have to do is equals to median. Literally type median and then select the values and enter. That's your median. Is the one in the middle. Okay. So the mode is the one that happens more often. So we can go ahead and type mode and just go over here. Well, you don't see any repeated values here, do you? Let's say that over here, instead of 78 was a 77. Notice how it's going to change over here. Now my mode is 77 because it's the one that happens the most. But since we don't have any repeated values, we don't have values that happen the most, that therefore it says it's not apply. Okay, so if you see that error, make sure your data doesn't have any duplicate values. Not duplicate values, that's incorrect. Like we could have grades that were 76, 76, 86, 86, 84, 84, or 84, 84, and 84 three times, and you would put on your mode. But if you don't have repeated values, then it's gonna say not apply. Okay. For your standard deviation, this is the tricky one. Excel has two formulas. Excel has standard deviation of your population and standard deviation of the sample. Most of the times you're going to be using the standard deviation of your sample. Right here it tells you calculate standard deviation based on the entire population. Calculate estimates the standard deviation based on a sample. What is the difference? If I tell you that the university has 7,000 students and I'm just gonna research a sample of, I'm gonna do a survey and only use 300 students out of my 7,000. My population is 7,000 students. My sample is the 300 that I'm selecting. Since we don't know, we just got this, we don't know if these are all the grades for the class. I'm just gonna say that's the sample. So I'm gonna use this formula over here. Okay. I don't know how many students are in class. It just says these are the grades, but I really don't know if there's any other students that were included here. So I'm just gonna use the sample to be on the safe side. I'm gonna select the values, and this is my standard deviation value, 11.94. Let's make it smaller. It's about 12. Okay, so my standard deviation, that means if you would look in a bell, but you're gonna learn that later on. If it's a bell curve, let's say that your average value, your mean is 79.3. When you learn the bell curve, you're gonna learn that we have the one, let me put it, one standard deviation. Actually, I should put it on the bottom. One standard, why is it? Oh, it changed all to the white. Okay. Why? So one standard deviation, two standard deviations above, three standard deviations above the average. This is my mean or my average, okay? Right here. And right here, you're gonna have one standard deviation below, two standard deviations below, and three standard deviations below, okay? When you learn this, let me see if I can get a picture for you. 1 second. Um, okay, let me get one that is not so a simple one. Oh, actually has all the values. Just trying not to. Here you go. This is good enough. Gonna put it over here. So right here is your mean or your average where your standard deviation is considered 0. Then we have one standard deviation above the mean, two standard deviations above the mean, three standard deviations above the mean. Then we have one standard deviation below the mean, two below the mean, three below the mean. You're going to be learning everything about central limit theorem and confidence intervals, all that you're going to learn. And then you're going to look at this bell curve and it's going to make sense that if you add all these percentages is 100%. Right in the middle, that's going to be 50% this side, 50% this side. And these are just the parts being one standard deviation, 34.13%, and then this side as well. We're going to go more in details later on. I'm just trying to give you an idea. So right here, it's telling you that my standard deviation is 12. So my next value, if I would do one standard deviation above the mean, I would do my average or my mean plus my standard deviation, which is 91. If I do two standard deviations, I'm going to have to do this value plus two standard deviations times right here. And then for the three, we're going to do equals to my mean, my average plus three standard deviations times my standard deviation. And now we're going to be doing it for the lower side. So we're going to do the same process, but now we're subtracting. To the left, we're going lower side, less. So subtract. To the right, we're going to add. So right here, we're going to do equals to 79 minus, so just one standard deviation. Then right here, we're going to do 79, which is my mean, my average, minus 2 times my standard deviation. And then over here, we're gonna do equals my average, my mean, plus minus, sorry, subtracting 3 times my standard deviation. So these are my values above and below. Instead of doing that, just do like this. Okay, perfect. This would, let me see if I can fit this up. More sense. So this pretty much would be this information right here. Let me make it a little bigger. Here you go. So if I ask you on the midterm, what is one standard deviation below the mean? Well, you don't have to go through all this trouble, So just gonna go equals to my mean is below, one below, so minus one. Or you could do this, or you can do 1 times 12, which is my value right here, okay? And then if I'm asking you 2 above, so you already know it's right here, so you're going to go equals to the mean plus 2 times my standard deviation. And these are your values. So just go ahead and look at all this value. If you want to make it whole numbers, that's fine, integers. Okay, just go ahead and take a look at all this information. Uh, don't get you. We're gonna go over all this in details later on, so it's gonna make more sense.